2.1, the distance and midpoint formula. So you will need to memorize these formulas for the test and the final. If you don't have them memorized, flashcards. I was that type of person. I had to use flashcards. Or every time you do a distance problem, write the formula. Every time you do a midpoint problem, write the formula. Then I promise by the end of your homework, you'll have it memorized. Every time I write it, you should write it while you're watching the video. All right, so the distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. The midpoint formula is a point, xy equals x1 plus x2 over 2, y1 plus y2 over 2. Let's find the distance between the points -4, 5, and 3, 2. So since it says distance, we're going to be using the distance formula. So we have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And since it's a formula, all we do is just plug it into our handy dandy formula. Now I will tell you where most people get things wrong. Now I've been teaching this class for 6 years now, and where people get it wrong, they don't label their points, and then they put the wrong numbers in the wrong places. Trust me, I'm guilty when I don't label my points. Label your points. If you label your points, oh my gosh, life will be so much easier. Label your points. So x1, y1, x2, y2. Just like when you did the slope formula back in the day, label your points. Label them. You don't have to, but it's so handy. All right, let's plug them into our handy dandy formula. So we have the square root of x2. So x2 is 3. See, when I look back to the points, my eye goes directly to the 2. So I know directly to look at that little x2. So we have 3 minus x1. So x1 is -4. And that's all squared plus y2 minus y1. So y2 is +2. y1 is +5. And that's squared. My 5s are horrible. You'll get used to it. I'll tell you if it's an S. I will tell you if it's an S. If I don't tell you it's an S, it's a 5. All right, let's simplify. So we know the positive and positive become plus, or negative and negative become plus plus. So we have 3 plus 4 is 7 squared, plus 2 minus 5, that's -3 squared. We're going to take the square root of that. So keep simplifying. We have 7 squared is 49. -3 squared is 9. And we simplify that to 49 plus 9 is 58 units. So the distance is 58 units. You are going to simplify if you can. So simplify if you can. You'll see that in example 2 we'll be able to simplify. You'll see what I mean by that. Okay. Let's do example 2. This is where I suggest you pause it, try it on your own. If you can't remember how to simplify or you're not sure what I mean by that, just wait until you get to the square root. But you should know how to simplify radicals. You're in college algebra. You know how to. If you have trouble with radicals, go to my YouTube and literally look up radicals. I have so many videos, or you can email me and I can send you the videos directly that can help you with this. All right, so since it says find the distance between these 2 points, we're going to use the distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. And what we're going to do is we're going to label our points. So x1, y1, x2, y2. Let's plug them into our handy dandy formula. So we have the square root of x2 minus x1 plus y2 minus y1 squared. I like to do a shell and then fill in the shell. So anytime I have variables, I like to leave little gaps and then plug in those numbers. So we have x2, which is +2, minus x1, which is +4, plus y2, which is +5, minus y1, which is -3. All right, that negative and negative become plus plus, so let's keep simplifying. We have 2 minus 4, which is -2 squared, plus 5 plus 3, which is 8 squared. So keep simplifying. -2 squared is 4. 8 squared is 64, and we can simplify this to the square root of 68. So what do I mean? Can we keep going? We can. We can actually simplify this more. So if you have a calculator, this is what I suggest you doing to simplify radicals. So with your calculator, what I would do is I'm looking for a perfect square. So I would do 68 divided by 4. 68 divided by 9, 68 divided by 16. You see how those are perfect squares? And then I wait till I get a perfect number. So 68 divided by 4, I get 17. That's perfect because 17 is prime, and I can't simplify that anymore. So the two numbers I'm going to use are 4 and 17. So I'm going to simplify this down into square root of 4, square root of 17. The reason why we do that, because the square root of 4 is 2, and square root of 17 stays that. So the distance is 2 square root of 17 units. If you want the approximate answer, just plug in square root of 68 into your calculator. You'll get the approximate answer. All right, that's review. Example 1 and 2 is review. That's what a lot of this class is review, and taking what you know and like at the end of the lessons kind of taking it one step further. That's what we're doing in this class. So this is a new example. Consider the 3 points. A is negative 2, 1, B is 2, 3, and C is 3, 1. Let's plot each point and form a triangle. We'll figure out the rest later. So let's plot the points and form a triangle. Plotting the points, that represents a coordinate plane. So if I look at my x's I have negative 2, 2, and 3. So those are the only x's I'm going to have on my coordinate plane. So for my x's, I'm going to have negative 2, 2, and 3. Those are the only x's I literally have. And in the middle, isn't there a 0? All right, there's always a 0 in the middle. And then for the y's, so for my y-axis, I have 1, 3, and 1. No negative numbers. So I'm only going to put 1 and 3. That's all I need. That's all I need. So now I'm going to graph it. A, we have negative 2, 1. So that's A. B, we have 2, 3. And C, we have 3, 1. And then we're going to form our triangle, meaning connect the dots. Okay, awesome. Why do we do it? Because it told us to. All right, now part B is find the length of each side of the triangle. Okay, that's easy. I can do that. That's just distance. Find the length. That literally just means distance, which is great. So length just means distance, and we know what that means, the distance formula. So for part B, we need to find the distances between all the points. So we have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. All right. So what do I mean distances between points? So what do I mean by points? We have point A to point B. We have that distance, that segment. Then we have segment B to C. And then we have segment C to A, but C to A, that just sounds weird. So we're going to say A to C. Although, could you do CA? Absolutely, it doesn't matter. They mean the same thing. So now we need to find the distances between all those points. Now, to be extra super duper super careful, what I would do, and I'm not kidding, I literally do this. If I don't, I will mess up. I'm going to write the points out so I don't forget what I'm actually doing. So I have A, which is negative 2, 1. I have B, which is 2, 3. And I'm going to do the same thing here. So for AC, so A, I have negative 2, 1. And for C, we have 3, 1. And then BC, So for B, we have 2, 3. And for C, we have 3, 1. This way, I don't mess up looking at my points. Because if you have 3 points here, you can see how it'd be really easy to look at the wrong point. I'm a glasses wearer. I'm really blind sometimes too. Like, I need to list things out for myself. It's true, list it out. You don't have to. These are just things that I suggest you doing if you're not the best person at math. If you're that person who's like, man, I am really scared to take this class, do what I'm doing. And there's a reason why I'm doing it. I do it that way every single time, and I try to not leave any gaps, make it all known for myself. All right. So, just like before, we're going to label points. So x1, y1, x2, y2, and we're going to plug it into our handy dandy formula. So we have it up on top, thankfully. So we have x2 minus x1 plus y2 minus y1 squared. All right, let's go ahead and plug in our handy dandy numbers into our handy dandy formula. All right, we have x2, which is positive 2, minus x1, which is negative 2, plus y2, so y2, that's 3, minus y1, which is 1, so that negative and negative become plus plus. Let's simplify. We have 2 plus 2 is 4, so 4 squared plus 3 minus 1 is 2 squared. 4 squared is 16, 2 squared is 4. Now we have 16 plus 4, which is 20, and we can simplify 20 into the square root of 4 times the square root of 5. My bad. I was right, never mind. And we can simplify that to 2 square root of 5 units. So the distance between A and B is 2 square root of 5 units. Now part B told me to find the length of each side. That's why I boxed the length, because it told me to find the length. So I did. All right. Now we're going to move on to BC. This is where I suggest you pause the video, find the other two lengths, find BC, find AC, skip to see if you got it right to the end. If you didn't, go back and let's work it out together. Okay, so maybe you skipped, maybe you didn't, maybe you tried it. I don't know your life. Let's keep going. So hopefully you tried it. I can't make you, but I really wish you would. So let's label our points. We have x1, y1, x2, y2. Take the second it takes to label them. Please label them. So we have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. That's going to happen. All right, let's plug it in. So we have x2, which is 3, minus x1, which is positive 2, plus y2, which is 1, minus y1, which is 3. And from here, we just simplify. So 3 minus 2 is 1, so we have 1 squared, plus 1 minus 3 is negative 2 squared. So 1 squared is 1, negative 2 squared is 4, 1 plus 4 is 5. So square root of 5 units. So that means the distance between B and C is square root of 5 units. All right, last but not least, we have AC, so we're going to label our points. We have x1, y1, x2, y2, and we're going to plug them into our handy-dandy formula. So we have x2 minus x1 squared plus y2 minus y1 squared. Let's go ahead and simplify, or not simplify, plug in our points. We simplify afterward. All right, so we have y2, which is 3, my x2, which is 3, minus x1, which is negative 2, plus y2, which is 1, minus y1, which is 1. All right, let's simplify. That becomes plus plus. So we have 3 plus 2 is 5 squared. 1 minus 1 is 0, so I'm not going to put that. So we have, you might remember same power, same index rule, but let's keep going if you don't. So we have 5 squared, which is 25, and that just comes out to 5 units. So AC is 5 units long. Alright, so now that we have all the distances, that was part B, let's move on to part C. Verify that the triangle is a right triangle. Okay. How the heck do we do that? So verify, that's might be a new word for us in math. That means to show work. So verify means your work is the answer. There's no X is this, distance is this, here's the answer boxed, nice and neat. Nope. Verify means all of the work you decide to show is your answer. And I need to be able to follow the work. But this, it's easy to verify a right triangle. So we're talking about right triangles. So part C. We know a lot about right triangles. So when we think of a right triangle, we should think of a popular theorem to do with right triangles, right? You might know this. Right? You might think of the Pythagorean theorem, a squared plus b squared equals c squared. That is the literal, I mean, it depends. You could have taken pre-calc and trig in high school. I don't know your life. But right now, where I know where you're at level-wise, that is the only thing we can correlate to a right triangle, that a squared plus b squared equals c squared, which actually means leg squared plus leg squared equals hypotenuse squared. And we know something about the hypotenuse. The hypotenuse, that is the longest side. The legs are interchangeable. Leg is whatever. You just need to find the hypotenuse, which is the longest side. Didn't we find this all the sides? Didn't we? Yeah. So the largest side is AC. How do I know that? Because if you plugged AB into your calculator, you would get 4 point something. If you plugged in square root of 5 into your calculator, you get 2 point something. Those are all smaller numbers than 5. So I know the hypotenuse is AC. So by default, the other two are legs. It doesn't matter what they are, which is the other two are legs. So AB and BC. So that's the formula that we're going to use for this specific triangle. So for this specific triangle, it is AB squared plus BC squared equals AC squared, because AC, that's just the longest side. So we know AB. AB was 2 square root of 5. Now, I don't want to use that simplified version nonsense. When we're plugging into the Pythagorean theorem, use just the radical, so square root of 20. So for AB, that's the square root of 20 squared. For BC, that's just the square root of 5. And for AC, before we simplified it, it was square root of 25. So the reason why I do that, because it's called same power, same index rule, there's always that little 2 there. Since there's always that little 2 there, the radical and the squared goes away. Same power, same index rule. So we're left with 20 plus 5 equals 25. 25 does equal 25. So this is a right triangle. So this is a right triangle. How do I know that? By showing all the work I did for C. You have to prove it. The A is not proving it. B is not proving it. C is proving it. So if I say, if question 5 on the test asks verify that this is a right triangle, you have to do part B to get to C. So part B is a step you have to take to verify right triangles. All right. So for part D, we need to find the area of the triangle. So area of a triangle is 1/2 base times height. Now, what if you forget that? Don't you know the area of a rectangle? So a rectangle, isn't that base times height? Right? Area is base times height. Isn't a triangle just half of a rectangle? Half of a rectangle? See? Stuff makes sense. It does. All right, so just in case you ever forget, it's half base times height because a triangle is half of a rectangle. So Your base and your height, those are just your legs. So if I asked you to find the area of a triangle, you need to identify the legs. In order to identify the legs, you need to find the distances between all points. So our legs, we had those values. So we have 1/2 times base, which is the square root of 20, times height, which is just another leg, square root of 5. So we simplify. Square root of 20 times square root of 5 is square root of 100. We know the square root of 100, it's 10. And half of 10 is 5. 5 units squared. Remember, area is squared. Want to know why it's squared? Because we're working with base and height, meaning 2 dimensions. Isn't volume cubed? Because you're working with 3 dimensions. And so on. There's an infinite amount of dimensions. Alright, example 4. If 4, -2 is the endpoint of a line segment, and -9, -1 is its endpoint, or midpoint, find the other endpoint. So I'm gonna graph what it's what it's giving me, because this seems like there's a lot going on. So if I were to draw a number line, or excuse me, a coordinate plane, which is just 2 number lines, we have a point at 4, -2. So let's say, oh, that's really big. 4, -2, let's say that's right here. Then we have a midpoint at -9, -1. So -9, -1. So that's our endpoint, or excuse me, midpoint. Now it's asking us to find the other endpoint. So theoretically, isn't the endpoint going to be somewhere around here? Theoretically, be down a little bit. Theoretically, isn't going to be somewhere around there? That's what we're asking for. What is that point? Isn't the midpoint directly in the middle of the 2 endpoints? It is. That's what the midpoint means. It's in the middle of the opposite sides. So if I know that, however much this distance, isn't it the same distance here? It is, because it's midpoint, middle. So I just need to find the distances between x and y. So what do I mean by that? From 4 to -9, so using my fingers, I'm going to count. So 4 to 3, 2, 1, 0, -1, -2, -3, -4, -5, -6, -7, -8, -9. I counted 13 on my fingers. So that's -13 to get to 4. So if this distance here to here is -13 with the x's, isn't this distance right here another -13? So -9 minus 13, we get -22. That's the x of the other endpoint. That's what we just found. We found the x. So this would be -22. We found this. Now we need to do the same thing to find the y. So to find the y, from -2 to -1, I plus 1 on my y's, because you would rather owe me $1. You don't want to owe me $2. You want to owe me $1. So I go up 1. So I plus 1. That means this distance for the y's, it's plus 1. So from here to here, I need to plus 1. So for the y's, it's -1 plus 1, and we get 0. So that means this point right here is 0. So the other endpoint, the endpoint is -22, 0. You could also use the midpoint formula. That is review. That's why I don't teach it. I'm trying to teach you another way to look at things, because we know how to count distance and stuff like that. All right, let's actually use the midpoint formula. So find the midpoint formula, or find the midpoint of the line segment from P1, -5, 5, to P2, 3, 1. So the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. Because remember the midpoint, that's x, y. It's a point. So label our points. We have x1, y1, x2, y2. So we label our points. Let's go ahead and plug them in. I always like to do the shell and then plug in stuff. So we have x1, which is -5, plus x2, which is 3. And then we have y1, which is 5, plus y2, which is 1. And from here, we're going to simplify each piece. So -5 plus 3 is -2. -2 divided by 2 is -1. Then we do 5 plus 1 is 6. 6 divided by 2 is 3. So that's our midpoint. So smack dab in the middle of those 2 points, we have -1, 3. All right, example 6. A car and a truck leave an intersection at the same time. The car heads east at 30 miles per hour, while the truck heads south at 40 miles per hour. Find an expression from the distance apart d in miles at the end of t hours. So find an expression, that just means like kind of like come up with a formula, come up with an equation. So we're going to come up with an equation for the distance that they are apart. So we know that. We know that distance. We know that formula, which isn't an equation. So distance equals x2 minus x1 squared plus y2 minus y1 squared. Awesome. We're getting there. We're getting there. All right, so a car and a truck leave an intersection at the same time. All right, so we have our intersection. It's boom, right there. So for an intersection, so think of like a normal intersection. Can't you go 4 ways, right? You can either go straight, left, right, or you can make a U-turn and turn around, right? There's only 4 ways we can go. We can go never eat soggy waffles. I love shredded wheat, so I don't like to say never eat shredded wheat. I love mini wheats. I love me some frosted mini wheats, but I love to say never eat soggy waffles because no one's gonna eat a soggy waffle. You shouldn't eat soggy waffles. Also, fun fact: my brother would microwave his waffles. He wouldn't toast them, wouldn't put them in the oven, nothing. He would microwave them. He liked soggy waffles. Yes, we're related. We're half related. It's the half that probably isn't related to me. That soggy waffles. Anyways, never eat soggy waffles. And we go in clockwise. All right, awesome. And we have 2 vehicles. We have a car. The car heads east at 30 miles an hour. So at the intersection, it's going east, this way. It's going that way at 30 miles per hour. Okay, awesome. We'll get there. We'll get to the 30 miles per hour. Then we have a truck that's going south at 40 miles per hour. So the truck is going south at 40 miles per hour. Don't worry, we'll get to the miles per hour in a second. All right. So for our car, we don't know where they're going, right? They just end up somewhere. They're just driving, right? And don't they end up at a distance of some sort from the intersection 0? Because did I go up and down at all? No, because this is on the X number line. So I went only directly on the X number line, some type of distance. I didn't go north. I didn't go south. I just went straight to the right. So that's D0. And then but again, I don't know the distance. So it just represents D. I'm just driving for some amount of time. And then for our truck, it's heading south. So it's heading down. So I didn't go east. I didn't go east or west. So I just went down. So I didn't go left or right. That's 0. But I did go down a distance. It's a different distance because I don't know how the truck is going. So it's distance 2. Because it's a different distance. They're all different distances. But it's negative because we're going down in the coordinate plane. We're going south. South is negative. Same as west is negative. North and east are positive. Okay. Now, with our two vehicles, we have our car. So our car, which is distance 1, it's going 30 miles per hour. Is it miles per hour time? It is. Miles per hour is some kind of time. I'm doing 30 for this amount of time, right? And then we know that that was distance and 0. Don't we know the distance? Isn't it some type of amount of time? Isn't it 30 t 0? Why am I allowed to do that? Because I know we're traveling for 30 miles per hour, which is 30 time. So D represents 30 time. So I travel this way for 30 miles an hour for who knows how long. Doesn't matter. And guess what? That's x1, y1. Awesome, right? All right, let's move on to our truck. So our truck, it's distance 2 and it's going 40 miles per hour. Remember, miles per hour, that's for some amount of time. We don't know it, so it represents time. But since it was going down, it has to be negative. But we'll get to that because we know that point. The point was 0, negative distance 2. So we have 0, negative, and our distance, which was 40t. And that's our x2, y2. Let's plug them into our formula. So we have distance equals x2 minus x1 squared plus y2 minus y1 squared. So we have x2, which is 0, minus x1, which is 30t. Then we have y2, which is negative 40, t minus y1, which is 0. All right, let's go ahead and simplify. So we have negative 30t squared plus negative 40t squared. Let's simplify. Negative 30 squared is 900. And t squared, remember, goes to both. T squared is t squared. And we're going to add that. And get rid of those parentheses. We can add that to negative 40t squared. So negative 40 squared is 1600. And t squared is t squared. We combine like terms to get 2500 t squared. And I know the square root of 2500. It is 50. And the square root of t squared is t. So the expression we would use to simplify this is d of t equals 50t, meaning distance over time equals 50t. That means the distance is relative to the time, because however long you travel, isn't that going to determine how far you've traveled?